Okay, we are now recording. Let's get the slideshow set up from the current slide. Good deal, thank you. Okay, we're in on page 376, chapter 7, Techniques of Integration, section 7.1. We're talking about integration by parts, and they don't have example 6, a slide for that, so sorry, can't use the thing. I believe this is where we were last time. Derive the reduction formula, and here is a, oops, let me get my pen set up. Oh yeah. Well, you can't see that? What's wrong with you? Put it on your x-ray vision. Hold that button down longer than most of them. Okay, sorry we're late getting started. Okay. All right, I'll start it. Derive this reduction formula. It's the integral of sine, I'm sorry. Screencast-O-Matic. Yeah, it started. Right here you see that's in case it's running. Okay. Sine to the nth power, yeah, x dx. Okay. They want you to derive the reduction formula. Okay. And there's okay. I'm not absolutely sure why this is in integration by parts section, because I don't think it's necessarily required. Yeah, well. Okay, it's a substitution. Well, no, they do this too. Okay, here's how they proceed. Okay, let u equal the sine to the n minus 1, which is rather bizarre. I know why. Sine to the n minus 1 of x, okay? Now this is a little strange to pick that to be our u, because that's not actually in the integral, is it? Okay? The dv is going to be sine x dx. Okay. What's that? No. Here, okay. Here's probably what they should have done first. This is bizarre, but it's true. Rewrite this as sine of n minus 1 to the n minus 1 of x times sine of x dx. Okay? Because isn't sine n minus 1 times sine to the n? Right? Okay. Give me a number for n. Make up a number. 6. Okay? If this was sine to the 6th power of x, isn't that the same as sine to the 5th power of x times sine of x? Yeah, right? So that's what they do first. They didn't do the step, but that's what they should have done. Then they say let u be that one, and let dv be that one. Right? All right. It's a trick. And if it works, we'll call it a method. Okay? So then, what's your next step? du is equal to what? No, n minus 1. N minus 1 times sine to the, you take the derivative of sine to the n minus 1, you get n minus 1 sine to the n minus 2, right? You drop it by 1, and you take a derivative. Right? Times chain rule cosine x. Right? Okay? Dx. Because you're taking derivative. Okay? Now let's do the integrate the dv. So you get v is equal to the antiderivative of sine minus cosine. Right? Because you're going to take derivative of cosine, you get minus sine. Okay, so that would be minus cosine x. Okay? Got it? All right. So your integration by parts takes the u and the v, multiplying those two together, and that would be sine to the n minus 1 x minus sine n minus 1 x cosine x minus the integral of v du, right? The bottom line there. And that integral would be, there is a minus in there, so that's going to make that a plus. And you'd have an n minus 1 on the outside, because that's just a constant, okay? And you would have a sine n minus 2 x times cosine squared x dx. Okay. That's your first iteration, okay? And by the way, that's the first term. Oh, wait a minute. Yep. Okay. That's not quite the first term that you have there, but it's close to it. You got the sine n minus, your minus sine n minus 1 cosine x. Sine n minus 1 x cosine x. What you don't see is where the 1 over n went, where it comes from. Don't worry about it. We'll get to that in a minute, okay? Because you sure don't get it from the first two terms. Oh, yeah, well, I'm sorry. You do on midway down the page. You don't have it in the block at the top, okay? So we're not quite there yet. So we have another step to do. But your minus, a minus cosine, so I've made that a plus, sine n minus 2, and why they split up the cosines, I don't know. Yeah, in the next step, they got it right. Okay. So they got the first two. Now, here's what you do next. Notice this has a cosine squared in it, right? Okay. We rewrite that as 1 minus, what is cosine squared? 1 minus sine squared, right? Now we'll have everything in sine squared. So instead of this, we write that. So let's write it down again. Minus sine n minus 1 x cosine x plus n minus 1 times the integral of, now we got two pieces here. The first part is a sine n minus 2x dx, and the second part, all this is by your n minus 1, is minus the integral of sine n minus 2 times sine squared. That would just be your sine n x dx. Yuck. Now, all right. Now I'm going to take away the brackets here because they're really not contributing too much. And what I'm going to do is multiply, take that one away too, okay, multiply through this n minus 1. Okay, just put it in front of both integrals because it does refer to both. Now what you see here is that that's what we started with, and it's equal to this, but that has the same term in it. It's just this is an n minus 1. So what we're going to do is add an n minus 1, add this to both sides of the equation. Okay? So that will give you, we'll add n minus 1 times the integral of sine nth x dx to both sides of the equation. Here's this side, here's this one up here, plus m minus 1 times the integral sine nth x dx. Okay. And when you add those two together, this goes out here because plus and minus. So what you wind up with is 1 plus n minus 1. This has been doing this all day. Just it skips to the next slide or shuts off. Times the integral of sine nth x dx is equal to the right-hand side is right here minus sine to the n minus 1 x cosine x. Swear. Okay. Plus the integral, wait a minute, n minus 1 times the integral, okay, of sine to the n minus 2 x dx. Okay. All right. When you add that to this side, you have 1 plus this, 1 plus that, times this integral is equal to, and this side is this one, this term here, plus n minus 1 times this integral of that. Now we have a recursive relation. Well, one exception. You need to divide both sides by 1 plus n minus 1, which basically is dividing by n, because you see 1 minus 1, that goes to 0, so this is dividing by n. So you have the integral of sine to the nth x dx is equal to 1 over n, I'll put minus 1 over n, sine to the n minus 1 x cosine x plus, goodness gracious, n minus 1 over n times the integral of sine n minus 2 x dx. Okay, so this now is your recursive relationship that you see at the top of the page. Okay? Near the top of it. It's not in your book, I don't think, is it? No. Okay. So here's what you get. This thing here, sine n, this integral here, is minus 1 over n times sine to the n minus 1 x cosine x plus n minus 1 over n times integral of sine to the n minus 2 x dx. Okay? That's the recursive relationship. Okay? Now, what I'm going to do, with your permission here, is to erase everything except that bottom line, because that's what we're going to use. We've got the formula they wanted, so let's erase all that. Okay. The pen is so slow today, I erase something and it takes several seconds before it really erases. I don't know if you can see that on the board. And it just jumps to other pages. It's just doing all sorts of weird things today. What's that?
The laptop is kind of old.
You're saying I'm old?
No, the laptop.
The laptop it's much newer than I am, I'll tell you that. Okay, yeah, it is old. But this was doing much better yesterday, so I think it's just having a cranky day today. I don't know why. It's just taking forever to erase this. But I wanted to keep our results, okay? Because the second part of the problem was using that result. All right, good deal. That's what we found the result to be. The second part of the problem, then evaluate the integral of sine cubed x dx. Now, there's no way we can integrate that any way that I know of, except by integration by parts like we just did. But since we came up with the recursive relationship, let's use that, okay? So this tells us this formula we have down here is equal to, what's our n? 3. So this will be minus 1/3 sine to the squared x cosine x plus 2/3, okay, times the integral of sine x dx. And guess what? We know what that antiderivative is, don't we? Negative cosine. So this will be minus 1/3 sine squared x cosine x, and because it's going to be a minus cosine, it'll be minus 2/3 cosine x plus c. Excellent. There's our answer. Once you got the recursive relationship, then you can do any power. 742nd power of sine. It'll just take you several pages, but you can do it. You just use it over and over until you get down to the end, where it's either going to be if it's an odd power, it's going to be a sine x. If it's an even power, you just have an integral of dx. So, that's what they got here. Let's see what they got. They got negative 1/3 sine squared x cosine x minus 2/3 cosine x plus c. You weren't just reading that, were you? No, you wouldn't do that. All right, yes, you were doing it on the board. Excellent. Good answer. All right. Now, in exercise 58, which I won't assign to you, you will be asked to derive the following reduction formula, and it's going to be similar. It's going to be the one for cosine, which will be the integral of cosine nth x dx. And you'll find that it turns out being not minus 1/n, just 1/n, the cosine n minus 1 x sine x, is it plus or minus? Plus n minus 1 over n times the integral of cosine n minus 2 x dx. Yuck! Okay. Now, you aren't responsible for that, but that is a reduction formula for that. So you can raise you can integrate any power of cosine. Okay? Any power of cosine. You get this. Very similar to sine. The only difference is instead of a minus here, it's a plus there. The main reason for that is antiderivative of derivative for cosine antiderivative of cosine is opposite sign. This antiderivative sign was negative cosine. So that's where that minus sign comes in. But the rest are just alike, only you substitute, you flip your sines and your cosines. Okay. Any questions? That finishes 7-1, and you know, it's silly me. I gave you all the tests for chapter 6 last time, didn't I? Yeah. Okay. I was yesterday when I was getting ready for class. I said, "Oh yeah, I need to make out this test." And I thought, "Oh, here it's already made out. Okay, I just need to make copies." So I made 2 more copies. So I'll have it for next term. You know, I've had one already for Theo, but he wasn't here yesterday either. So anyway, that finishes 7-1. Let's do the preliminary questions at the top of 7-1. I think I will just erase what's on the slide. If you got this, do you? Okay. So here's your preliminary question. Which derivative rule is used to derive the integration by parts formula? What rule do we use to derive the integration by parts formula? The product rule. Is that what you said? Yeah, product rule. Absolutely. And I'll check the answer, but I'm sure they got it right in the back. This is 7.1. Preliminary question. Integration part formula is derived from the product rule. Got it. Now, they only put the odd numbers back here, so we can't check number 2. For each of the following integrals, state whether substitution or integration by parts should be used. Okay? The first one, x times cosine of x squared dx. Would you use substitution or integration by parts? Substitution. Yeah, because let u equal x squared, du is 2x dx. There's your x, and 2 can come out as 1/2. So that's the substitution. Okay? The second one of these is the integral of x cosine x dx. X cosine x dx. Second? I couldn't hear it. Yeah. About what? It's either substitution or integration by parts. Integration by parts. Got it. Yeah, absolutely. You let your u be the x and the dv be the cosine x. All right, good deal. All right, the third one of these is integral of x squared e to the x dx. Integration by parts, absolutely. Let u equal x squared, dv would be e to the x dx. Very good. And the fourth one, integral of e to the x e to the x squared dx. What would you do for that? Substitution. Let u equal x squared, du would be 2x dx. You got the x dx, 2 would be a 1/2. Got it. Perfect. Y'all are good. All right, let's look at number 3. Why is u is equal to cosine x, dv is equal to x dx, a poor choice for evaluating this, the integral of x cosine x dx? Why would that be a poor choice?
It's supposed to be other way around. U equal to x and...
Right. You reverse it. You let u equal x and dv equal cosine x dx. Why? Okay. The first thing you do here is take a derivative. That doesn't get any worse. Doesn't get any better. Fine. Well, what would you have to do here? Integrate. Antiderivative, exactly. And what would that give you? X squared over 2. That's getting more complicated. So you want it to be that the dv part doesn't get any more complicated and this gets simpler. If you made the x here and the cosine x there, du would just be dx. That got simpler, okay? And the dv, the v then would be, a sine x. And that's no worse. So yeah, that's why that's a poor choice. Okay, let's see how they express it. They say transforming v prime into x into v equal 1/2 x squared, which is what you did, increases the power of x and makes the new integral harder than the original. Exactly what you said. Okay, homework exercises here. Any of the odds 1 through 5. And then they got a whole passel of them. Any of the odds 7 through 33. I would do some of the easy ones, some of those may be a little harder. Do number 35, okay, and they give you a hint to help you do it. And then do, excuse me, sorry, my head is clogging up. This is so cold in this room. Any of the odds 37 to 45, and any of the odds 47 to 55. Okay, then I would do any of the odds 57 through 65. Now, there's several different kinds of things there. Do some of all those that are different. And then do some of the odds 67 to 73. Then do any of the odds 75 through 85. Okay? And if you really want some more insights and challenges, you can do any of the odds 87 to 91, but you don't have to do those. Don't expect those on the test. Okay. Now we're going to go to another way of solving some integrals that are otherwise unsolvable, okay? And that will be in section 7.2. Taking its sweet time to open. Okay, here it comes finally, I think. Yeah. PowerPoint is really slow. Ugh. Okay. From current slide. Okay. All right. We have some examples to do before we get here. Okay. And by the way, does this look familiar? These are the last things we did. So that's what they did. The end of 7.1, they moved into 7.2. I'm sorry. The beginning of 7.2 in your book is at the end of 7.1 in the other book. But they do list them again here. No, they don't. Well, they do the special case of sine squared. Okay. We'll get there in a minute. Let's do this first. Many trigonometric functions can be integrated by combining substitution and integration by parts with the appropriate trigonometric identity. Okay, so this is these are called trigonometric integrals. In this section, we consider techniques for integrating various types of trigonometric functions. We'll begin with integrals of this form. Not quite that yet. We've already covered that. Let's see what the next thing is. That's one like the one we did. No. I'll do it here. The integral, see, one of the problems is the slide set is from the old edition, not from the new edition. So that's what gives me some problems here. So here's the integral of sine to the mth x times cosine to the nth power of x dx. Okay, where m and n are whole numbers, and the easiest case of these is when m and n, at least one of m or n, is odd. So that's what we're going to do first. And rather than derive anything, we're just going to do it. Okay? Evaluate this. The integral of sine cubed x dx. This is amazing. Okay? We just did that. We just did that using the recursive relationship we had before, and there really is no reason to do it again. Okay? And I hope they get the same answer. Okay. They get a different answer than they did at the end of example 6 in the other. And what they do is because they use a different identity. So this is really bizarre. Okay? It is totally strange what they're doing here. And they really set it up to do almost the same as what we did before, only they do, rather than using a recursive relationship, they do this, and it this is bizarre. The strategy of the previous example works. I just can't. Oh yeah, okay, I see it at the very beginning. We did the integral in example 6 of last section. However, we'll use a different method that is more broadly applicable, because sine of 3x is an odd, sine cubed x is an odd power. We split it off. So we really started the same as what we did before. Now, this is going to be a different technique. It gives a different answer, but what we could do is go back and say that those two answers are really the same. Believe it or not, they are, but we'll see. So here's our technique, and we started exactly the same way. We split this into sine of x times sine squared of x. That's sine cubed, right? Okay. And do this as an integral of sine of x times 1 minus, what sine squared? 1 minus cosine squared of x dx. Okay? Now, this can be written this way. Multiply through there, and you have the integral of sine x dx minus the integral of sine x cosine squared x dx. Right? You buy that? Yeah, okay. Distribute this. Sine x minus sine x cosine squared x, right?
Oh, okay.
Yeah. And then just split them into two integers. Is that fair?
So why do we still have sine x outside?
No, okay. All right. I'll do the step in between. That would be the integral of sine x minus sine x cosine squared x dx, right? Isn't that what happens when you multiply sine x times 1 and sine x times cosine squared x and sine x cosine squared x dx, right? Okay. Now, the integral of a difference is the difference of the integrals. Okay? And that's how you got from there to there. Okay? Now, I can do this one, can't you? Antiderivative of sine x is minus cosine x. Okay? Now, on this one, how would you solve that one? Substitution. What would you have substitute? Let u equal cosine x. Okay, then du is equal to negative sine x dx, right? Well, there's your negative sine x dx, so we can make this a plus the integral of, that is your du part, the minus sine x dx, this, and that all become du, right? And what are you left with? U squared. And I think you can do that one, can't you? This will be plus u cubed over 3, right? And then substitute back in, so it would be a minus cosine x plus cosine cubed x over 3 plus c. And that's exactly what they get here. They just write the cosine cubed x over 3 in front, which I like also. Cosine cubed x over 3 minus cosine x plus c. All right, now, the part that's a little confusing here is that equal to the same thing we got last time? What we got last time was, I'm just going to write down the answer, minus 1/3 sine squared x cosine x okay, minus 2/3 cosine x plus c. Okay, that's what we got the answer before. Okay, now, how can we rationalize this? Well, here's how. Cosine cubed is the same as cosine x times cosine squared x, right? Okay, so we could rewrite that as, and what is cosine squared x? 1 minus sine squared x. Okay, and that's all over 3, right? Now, split that up, and you get a cosine x over 3 minus cosine x sine squared x over 3, right? Well, this thing right here with that minus sign in it is exactly what we got on the first term there, right? Now, yeah. And that came out of the first one. But we still have a minus cosine x down here, and here we have a, so here, I can't talk. So we still have this minus cosine x down here, from here. That goes up here. Well, here we have a minus cosine x would be minus 3 cosine x over 3, wouldn't it? Okay. I just said that. Because you have a cosine x over 3 here, I'm going to write this minus cosine x as minus 3 cosine x over 3. Isn't that same thing? 3 over 3 is 1. Okay. So now we have cosine 1/3 cosine x minus 3/3 cosine x will be a minus 2/3 cosine x. So yeah, they are exactly the same. They don't look the same, but they are exactly. We didn't have to do that, but just because that left a bad taste in my mouth, work it at the end of the last section, you get one answer, and at the beginning of this section, you get a different answer. They're the same answers. Okay, that's all we're showing. They are the same answers. Okay. Now, but this is a more generic form. Anytime you have an odd power of either sine or cosine, use this technique. Factor out a single sine or cosine, and then the rest of them are going to be even. Split that up as the power of cosine or sine squared. Rewrite that as 1 minus the other squared, and you get everything in the same terms. Okay. So, let's do example 2. So I'm going to, y'all okay to erase? Okay. Now, evaluate this one. The integral of sine to the 4th x cosine to the 5th x. Okay, dx. All right. Sine to the 4th x, that's not odd. That's even power. But cosine 5th x, that is. That's an ugly looking 5, so maybe I should clean it up a little bit. I'm sorry, I can hardly breathe here. Okay. What you say?
Why they can't change the temperature? Here, this room is too cold.
Yeah, and what was your question?
Why they don't change it?
Well, I haven't called to ask, but they have it set. The old thermostat in here, I used to be able to adjust. They put a new system in here and then put in new thermostats they don't let us touch. They control everything over in whatever building it is, they do it. And I don't know why. Here's what I'm guessing the answer is, because I've asked it before. I haven't asked it this year, but they'll say, well, you see, we're still in cooling mode, and until we turn on the heat, the rooms are going to be cold. Now, once it gets cold and stays cold, then they'll turn on the heat, and then we won't be able to adjust the heat. But right now, they've just got it either, so there's all they got is chill water going to the system, no hot water. So there's no way they can crank it up. And what it is just chilly from last night, and it hasn't warmed up. Now, if it's warmer outside now than it is inside, we could open the windows. Have y'all been out? Was it warmer outside? It was still pretty cool. It was still cool. I'll go, let me just go see, because I imagine it still is. Probably going to be this afternoon before it warms up. So that's what they always tell me is they, at first it felt warm, because I think now that the breeze is coming in, it feels cool. So I can't tell. I wish we had it for longer out there to see. At first, when I opened the window, all that heat off the bricks and glass and stuff, that felt really nice, but then the wind started blowing and stuff was cool. I think it probably is still cool. But it's messing with my head. Okay, so here is our problem. Okay, that is a 5. It's not a very pretty 5, but it's a 5. So how would you suggest that we proceed? The value of it being an odd power is we can pull out a single cosine. So we'll rewrite this as the integral of sine fourth x cosine fourth x times cosine x dx. Okay? Now that doesn't look any better. In fact, it may even look a little worse. But now that we've got this cosine to be an even power, we're going to do something else. So let's keep the sine fourth x, but rewrite that cosine fourth x as cosine squared x squared. You buy that? Okay, times cosine x dx. That still doesn't look much better. In fact, it looks a little worse. But now is the place that we can do something different. Integral of sine fourth x, just carrying that along here, it's not doing much of anything now. But that cosine squared x can be written as one minus sine squared x. But that was squared, and then we multiply by cosine x dx. Okay? Now, next step is just sort of grunt work. Integral of sine fourth x times, we have to square that one. And what does that give us? Okay, no, sine fourth is already there. Okay, square just that term there. Oh, you were squaring the sine squared? Yeah. You were probably doing it right. I just do it this way. Square the first, 1, minus twice the product, 2 sine squared x plus sine fourth x. All that times cosine x dx. Right? That's an ugly sign. Okay. Now, you can square it any way you want to. You can write it off to the side and pull it however you want to. But the rule for squaring a binomial, square the first term, twice the product of the two terms, and since that one is negative, it'll be a minus 2 sine squared x, and then square the last term. And that minus always changes to a plus. You multiply that by itself. Okay? You buy that? All right. Now, what we're going to do is change this into 3 integrals. The first one is going to be sine fourth x times 1. That's just sine fourth x times cosine x dx. Okay? Got it? Minus 2 times the integral of sine fourth times sine squared would be sine sixth x cosine x dx. I pulled the minus 2 out, yeah. Got it? And then the third is going to be plus the integral of sine eighth x cosine x dx. Okay. Got it? Understood? And now really we do, and actually we didn't have to split those, I guess. We could have just multiplied through. But to me it's a little easier to see this way, but maybe not. What is your, how would you solve any one of those? And we could have kept that as 1. It was kind of silly to break them up, but what would be, how would you solve that? Say again? What do you say?
Take, I don't know, take the cosine off or something.
No. It's part of the integral. It's got an x in it. Substitution. Let. In fact, I think I'll do it up above, if that's okay. Ew. Okay. Let's let. What do you want to substitute? U equal sine x. Perfect. So what is that first integral going to be? And then du. Du is equal to cosine x dx, right? So what do we have here? U to the fourth du minus 2 u6 du plus integral of u to the 8th du. So I really didn't need to split them out as separate integrals. I could have all done all that in the same integral. And what does that give me? This will be u to the 5th over 5 minus 2 u to the 7th over 7 plus u to the 9th over 9. And then you could plug back in what u is, and that would be, I really should have done a plus c, but I'll do it at the end. That would be 1/5 sine to the 5th x minus 2/7 sine to the 7th x. Goodness gracious. Okay. Sorry about that. And plus 1/9 sine to the 8th. Is that right? 9th. I couldn't read my writing. 9th x plus c. All right. Let's see if that's what they got. Sine 5th, oh, they put it over 5. Sine 5th x over 5 minus 2 sine 7th x over 7. Yeah, I can't read my writing, but that's what it is. Plus sine 9th x over 9 plus c. Got it. Okay. Now, they give us a different problem. Okay? And what I think I'll do, rather than showing the answer, we'll work out the answer. Here's example 3. Evaluate this. The integral of sine squared x dx. Wait a minute. Not an odd power. So we don't have that same tool that we could do before. Okay? Okay. That's going to be the example 4 in this book. So that's example 3 in yours? Okay. So this is a bonus for you. You get to do, no, yeah, you get to do sine squared. Okay. Now, don't know how far back to go, if y'all like to see the derivation or just know how to do it. This isn't too bad. I'll show it to you. We've already been using that fundamental Pythagorean identity. How did it read? The Pythagorean identity. We used it already several times, just not in the standard form. Sine squared x plus cosine squared x is always equal to 1. Always. Okay. Now here's one that I don't know if you remember or not. Okay. Do you remember what cosine of a plus b is? You remember that one? Let me give it to you. Cosine a cosine b minus sine A, sine B. Okay. Now, if you don't remember those, the front, let me make sure it's here first. There's algebra, there's geometry, trigonometry. Front of your book, that, I got to sneeze, I'm sorry. Poor Theo listening at home. He didn't know that was coming, did he? Okay. All right. Doesn't do it in real time, but later. Okay. If you go to the front inside cover of your book, that page that says trigonometry, red trig at the top, on the right-hand side, addition and subtraction formula, there you see cosine of x plus y is cosine x, cosine y minus sine x, sine y. Right? Now, what if I said A and B, we could have done x and y. Let's just change that to x and y. Doesn't matter. Okay? What if x is equal to y, or y is equal to x? Then this could be cosine of 2x, right? X plus x, okay, is equal to cosine x is cosine squared x minus sine squared x. Ha! Okay? Well, let's go up here and rearrange this a little bit. All right, this is minus sine squared x plus cosine squared x is equal to cosine 2x. Wouldn't that be true? Okay. Now, let's subtract the bottom one from the top one, right? In other words, change signs and add. Make that minus and that minus. Okay? Now you get 2 sine squared x. These go to 0. Is equal to 1 minus cosine 2x. And then divide by 2. And now we have the integral of, I'm going to put the 1/2 out front, 1 minus cosine 2x dx. Right? Okay. Now, I don't know if you like to do it this way. I sort of do. That'd be 1/2 the integral of dx, that's 1 dx, minus 1/2, that's still out there, the integral of cosine 2x dx. How would you do that? The first integral we can do, what would that be? First integral will be it's just x, 1/2 x, okay, minus, we'll do the 1/2 here. Now, how would you do the integral of cosine 2x dx? What's your favorite answer? Substitution, yeah, I thought he would say that. What you reckon we're going to do is a substitute? Let u equal 2x. Then du is equal to 2 dx. We only have 1 dx, so let's divide both sides by 2. Sorry, I'm running out of room here. So this will be minus 1/2. That's already in front. And then we'll have another 1/2 from our du, the integral of, I've got to sneeze again. Sorry about this. Yeah. I'm sorry. I'm even sorrier for that. couldn't breathe anymore. Okay. The end of class. Oh man. Sorry. How's that time? I haven't checked time lately. We still got plenty of time. Huh? 10:55. So we got 15 minutes, right? I think I can make it till then. Okay. So this one minus 1/2 comes from there, which I already have written there. This one comes from the du over 2, and then you're left with cosine u du. And what's the antiderivative of cosine u? That would be sine u. Yeah, sine u. Yeah, minus sine u. Okay, but u is 2x, so this comes up being, this is all sort of messed up here, but 1/2 x, goodness gracious, quit doing that, 1/2 x minus 1/4 sine of 2x plus c. Now, that's not quite what they have in the book, though. Okay? Say again? Okay, well, yeah, but it's still got something else. Here we have a sine 2x. Let's go back to our double angle formula. Does anyone remember what sine 2x is? If you don't, we can do it the same way we did before. Let's do sine of x plus y. Did anyone remember how that went? Cosine x plus, no, I'm sorry, this is a cosine y, plus cosine x sine y. Okay, running out of room there. Sorry. All right. So if x is equal to y, then you'd have sine of 2x, right? Is equal to 2 sine x cosine x. There we have it. So instead of sine 2x, we put 2 sine x cosine x. So the 2 cancels that. So you have 1/2 x minus 1/2 sine x cosine x. The pen has gotten really, really slow. Plus c. That's the same answer. Okay. The pen slowed down, so I have that sign written strangely. And they just put x over 2 plus 1/2 sine x cosine x. Minus 1/2 sine x cosine x plus c. So that's what your sine squared x is. And they give it on the next slide. There it is on our slide. No, they don't. Ooh. Where do they do that? There it is. Okay, I knew it was somewhere here. It can either be written as, blow this up. They write it in both forms here on one line. Sine squared x, and we sine squared x is equal to x over 2 minus sine 2x over 4 plus c, or rewriting that as x over 2 minus 1/2 sine x cosine x plus c, because sine 2x is 2 sine x cosine x. So that's why plus c. Now, why they put this over 4 here and put 1/2 in front, you can write it any way you want to. They just, I think they're not too consistent here. But both of those, all those are correct answers. Okay? So that was the example 3. Okay? Now, it doesn't show up until later in the slide set because this is the previous slide. All right, so let's go back, and the next thing we're going to do is evaluate sine fourth of x, now that we know what sine squared of x is. Okay, so what I think I'm going to do is this will take too long, but I think it will be worthwhile. Going to integrate this with a fourth there, and we're going to do away with all this. I hope I'm not taking too much away here. This is taking way too long to erase because the pen is slow. Hopefully I won't need any of those, but if I need them, I can reproduce them. Okay. Now this is the result of what we had. Okay. The integral of sine squared x dx is either that or that. They're the same forms, the same values, it's just written in two different ways. Now we're going to do the integral of sine fourth dx. Sine fourth x dx. Okay, how might you think we ought to do this? Squared, I like that. Okay, the integral of sine squared x squared dx. Same thing, right? Just written differently. Okay. Now, before we would have changed this to 1 minus cosine squared, and then expanded that, but I don't think it gets you anywhere to do that. Okay? Yep, but that's exactly what they do. Okay? No, it's not exactly what they do. Okay? What they do here is rather than, now I wish I had kept them there. Okay, remember we had, I'm writing it in the same place. I'm going to rewrite the order though. Cosine squared x plus sine squared x is equal to 1. And cosine squared x minus sine squared x is equal to cosine 2x. Remember that? Okay. Now, so rather than using 1 minus cosine squared x, we're going to use what we derived here when we subtracted these, and those disappeared, and we had 2 sine squared x is equal to 1 minus cosine 2x, right? And then divide by 2, and that would then give you the integral of 1 minus cosine 2x. Let's take out that 1/2. It's out front. It's not going to contribute anything for now. Dx. Oh, this thing squared. Because that was sine squared. Oops, but then I better take out a 1/4 because I'm squaring that. This was over 2, square that, and you get the 1/4. So, sorry. Not too good to forget that. Okay? Now, if you square that, you get the 1/4 is out front, the integral of 1. Okay, you're doing the other one first. I usually do this. It doesn't really matter. 1 minus 2 cosine 2x plus cosine 2x squared. Okay? dx. Okay? Now, I can do this part of the integral and that part of the integral pretty easily. That part we can't quite do, but remember the same formula we have up here? This one? Now, what we do, another trick here, is add those two together. And what does that give you? 2 cosine squared x, these go to 0, is equal to 1 plus cosine 2x, right? Divide by 2, okay? And that gives you cosine squared of something is going to be 1 plus 1/2 of 1 plus cosine of double that something. So, in other words, this now becomes the 1/4 times, and I'm going to break them into integrals again. I sort of like doing that. It'll just be a dx, integral of 1 dx, minus 1/2, because the 2 over 4 is that, the integral of cosine 2x dx, plus, okay, wait a minute. If I do this, I need to have that 1/4 in front of it, so this becomes 1/8 then. Oh, no, I'm sorry, I already took care of that, didn't I? I thought, why did I forget that? But I didn't.
Do you mind if I sweep or should I come back?
I'm sorry?
Your room, should I come back to sweep it?
Yeah, we'll be through, and what time is it? We're through at 11:10.
Okay, that's fine. Just, could you leave it open for me?
I will. Okay.
Do you want me to clean the board?
If you would, that'd be great.
Okay.
Thank you.
We got 4 minutes.
We got 4 minutes, so we'll be out of here in probably 5. Okay. We already took care of that. I forgot that. Okay. Now we have plus 1/4, because that's still in there. Okay. The integral of, instead of cosine squared 2x, that becomes 1 plus cosine 4x over 2. Okay. When you have cosine squared of something, that becomes 1 plus cosine twice that. So we're going from the squared to this form. And that was a 2x already, so when you double that, it becomes 4x. You see, rewrite this as a u, okay? Cosine squared u is 1 plus cosine 2u over 2, okay? Now, what if the u was 2x? Then it would be 2x here and 2 times 2x here. That would be 4x. Okay? You see, when you go from the squared to this form, you lose the square, but you double the angle. Okay? So that now it's all right. So this is close to being doable. Let's see if we can do it. Why did I keep this down here anyway? I'm not using it, so let me get rid of it. Okay. I hope I won't need it. Okay. All right. So this integral here would be what? X over 4 minus 1/2 of, second, substitute, let u equal to x, okay, then du is equal to 2 dx, and then divide by 2, you get that. So this would then be, okay, all right. You had a 1/2 here, and you also have a du over 2, so that's going to make it a 1/4 here. Okay? All right? And that was then the integral of cosine u. And what's that? Sine u. Yeah. So it would be sine u, but u is 2x. Okay. So I get back to my 2x. Okay? Yeah, it's a negative sine u, but u was 2x, so I just put it instead of u.
So can we change the value in front of the 1/4 because it's negative and the other one is negative and it's going to be positive?
Okay, now say that again.
Okay. If that
Okay,
cosine,
it was a minus 1/2.
yes.
Okay, and then this came out as a cosine u, 1/2 du cosine u, right?
Yes.
Okay, so the 1/2 went to that, that's where the 1/4 came.
Yes.
The antiderivative of cosine u is sine u, right?
It's not negative sign. It's
No.
Okay.
Yeah, derivative of cosine is negative sine.
Yeah,
Integral of, sine u of cosine u is positive sine. Okay. Okay. Now, plus, we're starting out with a 1/4 here, but then you just have this over 2 here, so that's going to make it a 1/8, right? Okay. And then you have another integral here of a 1 plus cosine 4x dx. Okay. Now, you could break this into 2 integrals, or just say that first one is just going to be an x, isn't it? The integral of that, okay? And then the antiderivative of cosine is, okay, sine, but then you're going to have over 4 now, so that would be a sine, so it's going to be a plus, sine 4x over 4. Okay, that's what the antiderivative of that is. All that's multiplied by 1/8, so that would be 1/8 x, and then this would be, so the 1/8 goes with the x, but this combines with that to be a 1/32, 4 times 8. Okay?
We already took that 2 parts to the outside, right?
Say that again now.
So we already took the 2 in the denominator to the outside. So
This 2?
yes.
Okay, I hadn't here. That 1/4 came from here. That 1/4 is in front of that. And then we changed this, and that brought in the 1/2. So I took the 2 out here and made it 1/8.
Yes.
So I had done it there, and then I was just left with this to integrate.
Yes.
Well, this integrates to be x, and this integrates to be sine 4x over 4.
Okay.
But the 1/8 multiplies by both of those, so it's 1/8 of this, and 1/8 of this over 4 would be 1/32 of that.
Okay. What about the sine 2x? The before.
Okay.
Why we don't put the 2 over that sine 2x?
Okay, now what was the question again?
What I was asking, like, when that turned into like when we take the antiderivative,
Right.
it's sine 2x. I mean,
The antiderivative of cosine 2x, that gave us a sine 2x over 2. And that's what made that one, went to a 1/4.
oh,
Yeah. Okay.
I missed that part.
Yeah. I was just skipping some steps because we're running out of time.
I'll be confused.
Right. Okay. I shouldn't have skipped the steps here. So let's see what the answer is here. We have a 1/4 x and a 1/8 x. Those combine to be a 3/8 x. Okay? So it would be 3/8 x minus 1/4 sine of 2x plus 1/32 sine of 4x plus c. Okay. Now that's one way to express the answer. I think what they may do in the book is factor out a 1/4. I don't know this for sure. So let's factor out the 1/4. Okay. And that would leave us with a 3/2 x minus sine 2x. This is so aggravating. There we go. Wow. Okay. Plus 1/8 sine 4x, sine 4x. Plus c. Okay. Now, I don't know if that's how they leave the answer or not. No, they left it in the first way. 3/8 x, or 3x over 8, minus sine 2x over 4, plus sine 4x over 32, plus c. So they left it basically in this form here. Okay. All right. That was sine 4th. And now I'm guessing we must be out of time. We are. Okay, we'll begin next time with and then they rewrote it. Oh, no. Then they also went back and did it using that recursive relationship we did at the end of 7.1, that reduction formula. They went back and did it that way and came up with another answer, but it turns out being the same answer. It's just in a different form. Okay, so we won't worry about that right now. Oh, no, I'm sorry. That's not what they did. They went back from the double angles and fourth angles to sines and cosines. And if you want to, we can do that. So we may take this answer we got here and go from there. They have a little side note here too, integrating, and they give 3 cases here, and we'll look at those 3 cases later too. Let's see if there's any homework exercises in this set. And we basically came pretty close to finishing it. I think you can do any of the odds 1 through 5. And I think you can do number 7. Let's see, have we done 4 or 5? We've done 4, but not 5. So let's hold off the rest of those 9 and on until later. All right, and you got your test, so we're ready to go for the weekend. Got plenty of calculus to make the weekend fly by, right?
Yeah, but I work.
You work?
Yeah.
Sorry. Yeah. Well. All right, first let me do this.